Okay, in this video, I wanted to dive in a little bit deeper on test benches for digital logic circuits that we're going to implement in Verilog. Okay, so in the last video, we'd set up a really simple design. All right, so just an easy logic circuit. All right, so that was set up on the design side of the EDA playground, and this is similar to Vivado. Vivado has design source files, and so that's where that would go. All right, then we have a test bench. In Vivado, this would be a simulation file, and we had done this just linearly, step by step, giving all the different input combinations. I'd also set up this system command to monitor the output so it could go to a log file. What I wanted to do this time is get rid of this and talk about how we could program the test bench to where we don't have to delineate every case. We can get that to generate more in an automated fashion. So this would be important if we had, hundreds or thousands of input combinations to check. You'd want to be able to do that with some type of systematic approach. Okay, so it turns out what we're going to need is an integer counter. So Verilog has an integer data type. I believe it defaults to 32 bits. And test benches don't get synthesized, all right? It would be hard. It's not possible to, or not easily possible to synthesize delays. It's not easily possible to synthesize for loops, except under certain circumstances. All right, so what we're going to do here is we're going to use a for loop to generate our input combination. And the reason we define the integer I is the integer I is going to be our counter that we use in the for loop. Okay, so this is C-like syntax. All right, we're going to do all the input combinations 0 through 15. So when I is less than 16, we're going to stop, and we're going to do I is equal to I plus 1, increment the counter. I don't think that Verilog has a plus plus operator. Okay, and so next, it's tempting to put a semicolon, but you want to not put the semicolon. That would generate a syntax error. But you do want to, if you use more than one line, you do want to put a begin and an end. Okay, I could have done this all in one line, but let's use the begin and the end, and let's form AT, BT, CT, and DT by concatenating these things together and assigning them the count value. So concatenate just means put things in a row, just line them up. All right, so I have AT first, BT second, CT third, DT. It's going to take the integer value I, so when I is a 0, it's going to assign 0, 0, 0, 0 to these binary bit, single. These aren't vectors. These are single bit vectors, single bit quantities. All right, and I would also need to establish a delay between assignments, or else everything would just happen all at the same time. And that sets up a test bench with just a few lines of code. I should be able to generate all 16 combinations. And so when I hit run, it generated a syntax error, and it says it's in test bench line 6. I look, it says integer equal I, and the equal sign shouldn't have been there. Okay, it's just, I'm declaring an integer, it's integer space I. All right, so I fixed that error. Let's rerun this. And you can see, I'll move this up. I generate all 16 combinations, which effectively generates the truth table for this logic function. Okay, so that's a more compact way of generating all the test cases using a for loop. So I'd like you to be able to do that too. And you note the syntax. You do the start condition, the end condition, the increment, you could do, if you wanted just the even number, if you do I equals I plus 2. So you can play around with that to get it to do what you want. If you have a multi-line statement, you need a begin and an end, and I threw in this new thing where you can concatenate single bits into a 4-bit vector to assign the count value to those 4 bits. All right, so there's that. And one other thing I wanted to add in that you don't have to do in Vivado, because Vivado automatically has a method for generating waveform signals from test benches. All right, but in EDA Playground, there's a system command called dump file. All right, and we're going to do dump.vcd. So this is a file name. You tell it to dump to. And for now, just put parentheses 1. We'll talk more about the parameters for these system commands when we get to them. But for now, just dump parentheses 1, and this will have this opens up a file so I can generate waveforms to look at my simulation. Okay, again, you don't have to do this in Vivado. But this is how you set up a test bench, or set up waveforms. In EDA Playground. All right, so what do I do with that? Well, what I can do is under the run options. Oh, and by the way, you might hit an error where it asks you to, if you don't have what type of language selected, it's going to throw an error. So I selected Verilog, Icarus Verilog 0.9.7. For these simple cases we're running, that will work, and so will the other option, by the way. Okay, but if we want to open up the waveform after a run, you check this box, and when I run this, what will pop up is a waveform showing, here's the A test variable. So it's for the first 40 time ticks, it's 0. For the next 40, it's 1. The B variable, for the first 20, it's 0, then it goes up to 1, and down to 0. So you get the idea there, and you can look at the output F. And it's also showing the integer count value, 0, 1, 2, 3, 4. It's showing what I does, and I was defined as an integer. You could get rid of that and delete that and just have the normal things that you would want to see from this particular simulation. All right, so I wanted to show you that as part of the capability of EDA Playground.